screen clipping. Let's see if we can solve this problem together. All right, and yeah, I can't really blow it up very much. That sucks. Try to get half of it. And we paste it underneath to get the other half. Whoa, that's big. Too big. Keep asking me to fix this. We haven't gotten around to it. All right, so let's see, is that enough? No.
There's Sherman's being very. Even just the cuttings don't really around. Oh, shit.
Pain in the ass. Excuse my language in that, folks.
Shop-friendly versions in the field.
Okay, that's close enough. All right, so John took all his money from his savings account. He spent $52 on the radio, half of what was left on presents for his friends. John then put the remaining, I think that's supposed to be 4/3 of his remaining money into a checking account and donated $180 of what was left to charity. How much money did he have in his account? Okay, so this is one of those problems where you're gonna have to write stuff down repeatedly until you find something to do. Do we know how much money he had?
No.
No, okay, so we want to find that. So unknown, we have savings account total. Okay, so let's see, what do we know for sure? We know for sure he spent $50 on a radio. So we don't know the total yet, but we do know that the radio is equal to $52. Okay, what else? We have half of what was left to spend on his friends. Well, half of what was left. That would imply we knew what he had originally. So guess what we need here?
T minus half.
Variable. Okay, so T is going to be total. Okay. So well, what's left? Well, what would be left for, let's see, what are we doing with this? Presents. So I have to find half of what's left. Okay, well, what's left would be the total minus 52. Does that make sense? First, I have to take the total, subtract 52. That's what's left. And then I can take half of that. And so my claim at this point, that right there is what's left after buying the radio. T is my total. That's what he spent on presents. Okay, what's next? John then put three quarters of his remaining money. Oh, so we have to do another what's left thing. Okay. So 4/3 of his remaining money. So new color. And this is going to do what? What's after presents? 4/3 of it, checking. Okay, so next is checking. 4/3 of whatever's remaining. How do I find what's remaining? Well, what has he done so far? What's that?
4/13. Not 4/3.
Oh shit! All right. 13. Thank you.
Question.
Yes.
If we look at this and say that $180 is what left,
Yeah.
is what's left.
Yeah.
Out from the 4/13ths.
Yeah.
Could we say that 180 is 9 of the 13ths?
Yeah. Yeah. Because 4 and 9 is 13.
Okay,
So the 180 is 9/13ths of something. What is it 9/13ths of? What?
20.
Why 20?
Because 20 times 9 equals 180.
So a 13th is worth 20. Okay, so what does that tell us?
That 4/13 would be $80.
Oh, okay, so we could work back up. That's a good idea. Let's try it, see if it works. So let's get a new page, and I'll pick up on the algebra junk in a minute. So if 4/13 went to checking, the remaining 9/13 had to go to what is it going to? Charity.
Yep.
And that's $180. So we have 9 pieces that come up to $180. So one of those pieces has to be what? Question again? $20, yeah. So if we divide that 9 to the other side, 1/13 of whatever's remaining at that point has to be equal to 180 over 9, which is 20. So then we can hopefully back up and go from there. So let's see. As far as the checking goes, how many 13s went into checking? 4 of them, okay. So the checking is 4/13 of whatever was remaining at that point. Each of those 13s has to be worth how much again? 20. So that has to add up to 4 20s. That seems reasonable. And so that means into checking went $80. All right, so can we piece that back together? I'm running out of room. So this is not to any kind of scale, but let's say this is my total amount. Trying to figure out where we're at. We had some remaining amounts. After he did what? What did he do before we ended up with this remainder? Do you remember?
Bought a radio.
He bought a radio and
Presents.
presents. Okay. And we just calculated there was $180 plus another 80 in here. So there was $180 in here, and then another $80 that went to let's see, charity was this one, and checking was this one. So we're using pictures and proportions to try and solve this. We know that in here was a radio for $50.
52.
2, yes, thank you. 52. Let's fix that. 52. Problems. And then what was this other one here? Again, presents?
Yeah, presents.
Okay, so let's see, our presence is still unknown, but we have some clues to try and figure it out. What do we know about presence?
It was half.
Half of what was remaining after the radio. Okay. So again, I mentioned my picture is totally not to scale. I'm just throwing some information in here. This is what's remaining after the radio, right? And half of that had to be for presence. What happened to the other half?
Went to charity and check.
Went to charity and checking. So if charity and checking is one half, do we now know what the presence half has to be?
Yes.
It has to be what?
Combination.
Combination of those two, it looks like 260, doesn't it? Yeah. So it looks like that should be 260. So we can kind of piece it together with a picture. Okay, is there a chance this was like not right at all? I have no idea if this is right. It sounds good though, doesn't it, Christian?
Sounds pretty.
I feel good about it. Christian feels good about it. Anybody else?
The 260 is
Yeah.
the what's remaining, or that's what the presence was?
So first they said he spent $52.
Uh-huh.
Half of what was left went to presents.
Okay.
And then of the remaining after present, so I have a part I'm calling remaining, and this part in red, I'm saying that's what's left after the radio. So they talk about two different remainders here.
Okay.
Remainder after buying the radio, and then the remainder after buying radio and presents. And we're kind of backtracking from here, trying to piece it together. So I'm going to repeat this in a slightly different way and see if we come up with the same answer. Okay. So we think the total is whatever this adds up to. So 260 plus 260 is what, 520? 520 plus 52, 572. So we're thinking maybe the answer is 572. So I'm going to do another picture method on this, and then after I do the picture method, I'll try to go back and see if the algebra will work out, because we're supposed to know algebra too. Okay, so this is a wild guess. So how many would like plug that in and hit check my answer? Right, of course. But remember, that doesn't exist on a test. There is no check my answer button. So we got to try something else. So let's start over. So I'm going to draw a picture of the whole thing. So this is my total right here. And now I have to start breaking up the total. Okay. So the first thing we know is he spent 52 on the radio, right? Okay. Here is the radio. 52. Radio. Looking back at the problem. Half of what was left was spent on presents for his friends. Okay. All right, here's what's left, agreed? Even though it's on the right side, that's what's left. And we want to take half of that. So maybe I'll switch colors. So this half right here is for presents. Okay. Then what? Back. 4/13 of the remaining amount, so that must be that other half that was left over, went into a checking account, and the rest was for charity. Okay. So we have to split this remaining amount into how many pieces? Yeah, 13 pieces remaining. And so I'm just going to hope I can do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, make believe they're all the same size. They're close. And I know now that 4 of those 13ths, 1, 2, 3, 4, is going to checking. Checking for 13ths. And then finally, what's left? Anybody remember? What's this here?
180.
That's 180 or
9/13.
9/13. Yeah, it goes the same either way. So I could call that black area right there. Which color should I use? Red. I could say this is 9/13. I could also say that is 180. So does Christian's idea that of these 9 pieces, it's a total of 180? So each of those pieces must be worth what? If we have 9 pieces and the total worth 180, how much should each piece be worth?
20.
20, right? Because 9 goes into 180 20 times. So each of those slices has to be worth $20. How many slices are there altogether in this remaining section?
13.
There's 13 of them, so I have 13 20s, so it appears that this whole remaining section there has to be 20 times 13, or 260. Okay, how does the 260 relate to anything else to the left side here?
Wasn't that half?
Yeah, that's half of what was left. Okay, so what has to be in this part right here?
The other half.
the other half, which is another 260, right? And then there's the 52. So slightly different version of what Christian did. Are we getting the same answer?
The picture there is a lot easier to understand.
Okay, so can I tell you something about this picture? I did it 4 times before I wrote it with crayon and sent it to you two. I didn't get it right the first time. I messed it up a few times. It's a problem, right? We got to remember that sometimes we're going to fail when we solve problems. How many times did I fail?
Well, I was trying to do it the algebraic way that they
Let's-
showed in
Let's
the
do it. Yeah, and
algebras.
so bottom line is somebody wrote those solutions hoping that somebody was on this, everyone else is on the same brainwave pattern they are. And many people I explain this picture to twice will not get it. Like my mom will just walk out of the room after the second try. Like, sorry, Gary, I don't like that. She would also not like the algebra version, but I'm going to go over the algebra version anyway, and hopefully some of my explanations will help with the written one. So let's try this one more time. So we seem to get the same answer as the last picture. So I'm just going to restart the algebra stuff. So we have some unknown total. So we're going to say T is our total amount. And then I'm going to start writing whatever I can. So I know, let's say R, I'm just going to call it radio. I use just R. I know that the amount on the radio is equal to 52. Next thing that came up was presence. And we were told that half of what was left was spent on presents. Okay, well, how do I find what was left? Well, what was left had to be the total minus 52. Once I find that, then I can find half of it. So order of operations is pretty important there. So I've just gotten rid of 2 sets of money, right? So then he starts talking about the checking account. And for the checking account, he said, take a fraction of what's left now. Well, what's left now is the total minus the radio minus the presence. Agreed? That's where I'm at now. True? Okay. And then we want to take some fraction of this remaining portion there. Move the equal sign over a little bit. And I believe the fraction was 4/13. So we need to take 4/13 of what's left after doing the radio and the presence. So this has to be the remaining amount after radio and presence. Now I've got way too many variables here, right? I don't want to use a variable for radio and a variable for presence because I actually have defined what each of those means. So I can redefine this checking part. The checking is really 4/13 of the total minus, well, radio is easy, that's just 52, right? Minus presence. What's the presence worth? Half of parentheses, and I gotta write it like that. Half of the total minus 52. Close the presence parentheses, close the check-in parentheses. There's like 3 steps from being done at least. After checking, there was what? Charity. So the charity, in this case, was just 1/8. Right? It was a fixed amount, wasn't it? Kind of like radio. It's just so I can just go 1/8. And so here's what I know now. He bought a radio. He bought some presents. He put some money in checking. He gave some money to charity. All of that constitutes his total. So the total has to equal the sum of these things. And so now I have to put that all together into one equation. So let's try that on a new page. And did you guys write any of this down? Oh, good, because you're going to have time to put it back together. So new page. The total has to be equal to the radio, 52, plus the presence, 1/2 of parentheses t minus 52, plus the checking, which I think is 4/13 times parentheses, 52 minus 1/2. No, I'm missing something. I'm missing total. T minus 52 minus 1/2 of t minus 52. And let's see, that's radio, presence, checking, and then charity is next, so I still have to add the 180. And so now I have an equation with only a single variable that I have to now clean up. So that is the hardest part. So there's a t, so that's my only variable, it just occurs multiple times. And aside from the picture and Christian's perspective in this, coming up with this equation, I'm not sure of other ways to solve it. I tried a few other things that didn't work. So now we have to start doing distribution, combining like terms. So write that down and let's all see if we can do this, and I'll start doing work too. And yours will be a similar equation, but you'll have different fractions and slightly different numbers depending on the luck of the draw when you draw that problem up. But the same procedure should work. So I'm going to try and solve this. Please, you give it a shot too. Change colors. Actually, I might as well add 52 and 180 right away. Does that come out to 232?
Where you get that 232?
52 plus 180.
Oh,
Yeah, I figured I'd put those together right away. That's the 232. So then I have half of t here, half of 52 here. 4/13 of t goes here. I calculated 4/13 of 52 is 16. And it's positive times a negative, so it stays negative. And then here I have 4/13 of a half, which would be 2/13 times t gives me that. And then 2/13 of 52 I calculated to be 8. And I think it's a positive 8. Does anyone disagree there? Here I'm going to have a negative times a negative. So now we got to start cleaning this up. So we have more constants to add up. So I have to figure out 32 minus 26 minus 16 plus 8. So I guess I'll just scribble that here. 232 minus 26 plus 206, is it? Yep. Oh, shit. What? 206. And then minus 16 plus 8, I could really consider that a minus 8 altogether. So taking away 8 from that gives me a 192. Oh no, 198. Oops. 198. All right, so let's drag that out of the way. So the constants add up to 198. And now I have all these fractions to deal with the t. So remember, a variable is just like an object. I have half of that object, I have 4/13 of that object, and I'm losing 2/13 of the object. So I might as well do, this one's the easiest one to do because they have a common denominator. What's 4/13 minus 2/13? That's 2/13, okay. So that means I just have to clean up the remaining part, which is 1/2 t plus 2/13 t. So that means I need a common denominator, so we could either use the arrow algorithm or the lowest common denominator algorithm, which in this case are the same. And so, or the butterfly, let's do the cute little butterfly. 13, 4, 26. So according to the butterfly, I get 1726 t's. 17 out of 26 t plus 198 equals t. So this is a rarity in this class, doing this much algebra. Good for us. All right, what are we going to do next? Yeah, move the t's to the same side. So I would choose to subtract this guy to the other side. So I would have 1t minus 1726. What's 1 minus 1726? Can you tell me?
926.
It would be 926, right? Because 26 out of 26 is a whole. No. So I got to deal with 1t minus 1726 equals 198. Is that what it was? 1 is the same as 26 out of 26. So really, I just need to consider 26 minus 17. So 9/26 of t is equal to 198. How do I solve this?
So you divide that.
Divide by 926, okay?
So
So that gives me t equals 198 divided by 926. How do we do division of fractions? Multiply by the reciprocal, okay? All right, so that's 198 times 26 over 9. And let's see, 9 goes into 19 twice with 1 left over. 9 goes into 18 twice with nothing left over. So 9 goes into 198 22 times. So now I just need to know what is 22 times 26. And the calculator would be super helpful along the way here.
22 times 26,
Yeah.
572.
And is that a good number to see based on our earlier work?
Same answer.
Holy crap. I like the picture way better, but it takes some time to, get used to that picture, to believe it's right. First time I did it, I wasn't sure it was right. I checked my arithmetic and realized I made a little mistake, and I tried again. Got a different answer, tried it again, got the same answer. Was starting to feel confident, so then I did the algebra to make sure.
That's just a lot of stuff to algebra.
It is a lot of algebra, yes.
And I can see now where I got lost. So I seriously got lost within.
Well, the parentheses within parentheses within parentheses is pretty tough here. This is hard.
I think it was just coming up with that part right there is where it got me, because I could not figure out how
Yeah,
to evenly distribute.
So for the first time I did the algebra, I had to write at least this much stuff down to try and sort it out, to put it back together. So I had to label out everything. I wrote out things like t minus radio minus presence. I mean, I couldn't do it without writing all this stuff down.
It's definitely one of the harder.
Yeah.
And even
work
the
I've ever seen.
way if you click on show me how to do this,
Yeah.
it didn't have that many steps either.
They skipped some steps.
They did.
Yes, and they generally do skip steps on this with not much explanation. They just hope you can figure it out.
Yeah, expect you to.
Okay, so we've done it a few different ways, and we're coming up with the same answer each time. So I think now we're pretty sure that we got it right. And so now I will go to check my answer. That only took, what, half an hour? And this is like the 10th time I've done it this week. So it was a hard problem. Good job. I was hoping for a fantastic. I think we deserve a fantastic for that one. Okay, so I want to come back to a couple parts of what we did here. Then Kelly, you had a question on this or something else? Something else? Okay, we'll wait just a minute. So I want to get back to this right here and just talk a little bit. We did division models in class. We mentioned the division algorithm for fractions, but I just want to talk a little bit about why this conversion is okay. Does anybody have a thought about that we rewrite division is the same as multiplying by the reciprocal? How can we justify that? Any thoughts?
That's one where it's basically multiplied by itself. No? No? Yeah.
You can use the number 1 to justify this, yes.
Oh, I remember from that.
Okay. Does anybody else have thoughts on it? What's that?
Doesn't it sometimes depend on the denominator, because sometimes that can affect if you can multiply it as multiplied by the reciprocal be the same as division? Does the denominator being different throughout different equations affect the answer?
No. So with division, the only thing that matters is, algorithmic wise, is that you multiply by the reciprocal instead. Like division is exactly the same thing as multiplying by the reciprocal. So denominator doesn't matter. It turns out that idea leads to an alternate algorithm, but I'm not going to go over that right now. But why does it make any intuitive sense to you that this should be true? Okay, besides because you were taught that.
Because we found that it works.
Okay, you found that it works, but that's not a why. I mean, that's just an observation, right? So,
Because the numbers look like the same, aren't they? I mean,
what do you mean the numbers are the same?
when you flip them upside down, I know what I want to say, but I can't quite articulate it.
So let's try something else. So what's 12 divided by 3?
4,
How do you know that?
because I put 3
Minerva?
groups of 12.
Because 3 times 4 is 12, right? Because 3 times 4 equals 12. So how are multiplication and division related to each other?
The answer multiplied by divided. What's the second one?
This guy is called the divisor, and this guy is called the quotient.
So the quotient times the divisor equals the
Dividend.
dividend.
Yes, that's always true. Yeah.
Something to do with the picture you showed us.
Yeah. So this is groups of, and what's division?
Groups in.
Yeah, whereas division is groups in. It's just reversing that idea. And that's the important part. It's reversing that idea. So multiplication is the inverse of division, and division is the inverse of multiplication. So this is an important idea. So multiplication and division are inverse operations. Okay, multiplication and division are inverse operations. So there's a relationship between those two words up there. Next, what does reciprocal mean? Flip it, right? Reciprocal means flip the fraction. So let's see. So write down a couple of examples of reciprocal. Write something on your paper. 1/4 of 4/1. Two-thirds versus
3 halves.
3/2.
Or
So we're exchanging the numerator for the denominator. We're basically, and what is that fraction again? What does the fraction bar mean? It is division. Okay. Back here. So division and multiplication are inverses. And reciprocal, isn't that kind of an inverse too? Yeah. Which changes the multiplication and the division. So what happens if you take an inverse of an inverse? You get back to where you started with. Yeah, and that's what's going on here. Oops. Oh yeah. Multiplication and division are inverses of each other. Throwing the reciprocal in there takes an inverse of an inverse. So what's the reciprocal of 2/3? What's the reciprocal of 3/2? Takes us right back to where we started. Yeah. So that's what's going on here. We switch multiplication with division, there's an inverse. We do a reciprocal, we just did a second inverse, which put us back to where we started. And that's why they are the same thing. They're exactly the same thing. So that's one justification of it. See another one? Oh, Danielle's enthusiastic about that. That was a very good handshake. So we played with the groups in model to figure out what to do with fractions. And we used our little toys pattern blocks, right? Oh, yeah. What were some of our other models for what division meant when we were doing whole numbers besides groups in? That's a fraction model. Think back to whole numbers, last term, 3 months ago.
Repeated subtraction.
Repeated subtraction was one.
What do I multiply by?
Aha, that's the one I'm looking for. What do I multiply by? Division models. So I'm going to switch to that one next. So we've looked at the groups in model to justify what to do with fractions. Now we're going to take a look at the what do I multiply by? Does anybody remember the other name for what do I multiply by? What the book called it?
Missing factor.
The missing factor. The book called it the missing factor. So also known as missing factor model. So let's take 1/2 divided by 2/3 equals what? The way to use the missing factor model is to basically read that backwards. So we're going to rewrite it. What times 2/3 equals 1/2? And so we're going to try and figure out what to do here to make this happen. So is there a 3 in the denominator over here on the right side? So that means we have to find a way to get rid of that 3, don't we? Where could we put a 3 to get rid of that? Yeah, put a 3 on the top. So there has to be a 3 there. Okay. Is there a 2 in the top over here?
No, you need a 1 in
I need a 1 in the bottom. Over here?
the maybe.
Well, I need a 2 in the bottom for sure to get that right there, right?
So how are you gonna use the 1?
This one right there?
Yeah.
Oh, you'll see. Hang on. Just bear with me. So you agreed, we got to get rid of the 3, right?
Yeah.
Okay. We also have to get rid of that 2 right there, don't we?
Yeah.
So we need a 2 to get rid of that 2. But we also want a 2 left over, don't we? And so let's see what's going to happen. This 2 and this 2 is going to cancel, that 3 and that 3 is going to cancel. And what's going to be left with, what happens when you cancel anyway? What's left over when you cancel? Anything? Nothing?
1.
1, yeah. Because what we're saying is that a number divided by itself is a 1. A number divided by itself is a 1. And you can put that 1 in the numerator or denominator, whatever makes you feel good. You can put it in both places if you want. Okay, so it appears the answer here should be what? 3/4? Okay. Now to get that, let's take a look at something. highlighter, blue. What do you see right here? 3 halves, okay? Well, how's 3 halves related to 2/3? Reciprocal, okay? There's a 2 in the bottom there, right? Dividing by 2 is the same as what? Multiplying by a half. And so here's my 1/2 kind of hiding right there. So the what do I multiply by model, by kind of trial and error, leads you to multiplying by the reciprocal. It forces you to do so. That kind of makes sense a little bit. And with adults and kids, you got to do multiple examples to try and pick that up. So let's try another one and see what happens. Let's try, so you piece it together with the what do I multiply by. So how about 2, oops, that's a highlighter, sorry about that. Little pen, let's try 2/3 divided by 1/5 equals what?
Can you go back a page, please?
Yes. So 2/3 divided by 1/5. Okay. So that's kind of messy.
Okay. No, yeah, I was just seeing where.
Okay, so see if you can piece that together. So write it down underneath. Read it backwards. Remember, what times 1/5 is equal to 2/3. And see if you can build what you need in this box to get an answer. So you give it a try, and then I'll have you help me do it. All right, let's see if you guys can help me do this. So I want a 3 in the answer, right? Do I currently have a 3 on the left side?
No.
No, so I need to put a 3 in the denominator, agreed?
Yes.
Is there there needs to be a 2 in the answer, right?
Yeah.
Is there a 2 on the left side?
No.
I better put one in there. Okay, now coming back to the left side. Is there a 5 in the answer?
No.
So how do I get rid of it?
5 up.
Put the 5 in the top. Now, is there a 1 in the answer? No, but 1's kind of boring, but I could say I put a 1 down here to get rid of it. But 1 divided by 1 is 1. That doesn't change anything. So this seems to show that the answer should be 10/3, right?
Yeah.
And just looking at some stuff, this 2/3 here in red is that 2/3 above right there. And here I'm dividing by 1/5, but here I am multiplying by the reciprocal 5/1. Yeah. So if I go through what do I multiply by, which is a guess and check method, which is fine. Guess and check is great as long as there's some organization to it. It works fine. It shows A and multiplied by reciprocal. That works. And eventually kids will start seeing that if you do enough of these. Okay. Are they going to be able to figure this out on their own? 99.99% can't. I mean, we got to guide them through. Does this feel like it's coming natural to you yet? You should all say no. It's probably not, because it requires practice. You're already there, that's awesome, okay. But most of this stuff, it takes getting used to. Again, we take for granted why things are. Maybe we never knew why, we were just told, just do it, just that's it, okay? But we're kind of getting some reasons as to why. Inverse of an inverse cancels itself out, doesn't change anything. That's one reason. This leads to another reason when I try to piece together. All right, so let's move on to something else. What haven't we played with much? We have not played much with the idea of ratio very much, so we're going to move to that. I'm going to stop this recording.
I have a question.
Yes, how do I stop it? Here.